Now suppose we have the function w equals j of x, where w is the average daily quantity of water in gallons required by an oak tree of height x feet. So for this guy, our input is going to be x, and x represents the oak tree height in feet. The output is going to be w, which is the water in gallons. So what does j of 25 represent? So the input is 25. 25 is an oak tree of 25 feet. So an oak tree of 25 feet a 25-foot oak tree requires W amount of water. Now what does the inverse expression represent? Now the inverse, the input and outputs are reversed. So our input is going to be water. So 25 gallons of water are required for an x-foot tree. What is j of v equals 50? So we know v is our input, and this is our original function. So v is the height of the tree. So a tree, v feet tall, requires 50 gallons of water. Now we want to rewrite the statement j of v equals 50 in terms of the inverse. So we want 50 to be the input and v to be the output. So inverse j of 50 equals v. On a certain acreage, oak trees on average measure z feet high, and an oak tree of average height requires p gallons of water. We want to represent the statement in terms of j and then in terms of inverse j. So in terms of j, our original input is the height of the tree. The height of the tree is z. Our output is water. Water is p. In the inverse, we're going to reverse them. Inverse of p equals z. Number 6, the total cost C in dollars for clothing factory to make J jackets is given by the function C equals f of j. Interpret the meaning of the following notation with the context of the story. So in our original notation, the input is j, the number of jackets. The output is the cost to make them. So to make 30 jackets, it costs $678. So what does the inverse mean? So now our input is C, which is the cost in dollars. Our output is the number of jackets. So for part B, it costs $30 to make 678 jackets.